Hey there, this is Adrian Rosebrock here from PyImageSearch.com, and today we're going to start discussing what PyTorch is. This is our introduction to PyTorch module inside PyImageSearch University. You're going to learn about what the PyTorch library is, what it does, how it's useful for computer vision and deep learning practitioners, and of course, how it's different from Keras and TensorFlow and when you may want to consider using one over the other. So today we're going to start off with this basic introduction. You're then going to learn how to train your first neural network with PyTorch, then your first convolutional neural network with PyTorch, and also show you some ways that you can leverage pre-trained image classifiers and object detectors using PyTorch as well. After we get through this 101 style course on PyTorch, we'll move into more advanced techniques such as data loaders and how to customize them and make them super fast and useful for training your networks, as well as more advanced training procedures such as distributed training. And then finally, in PyTorch 103, that's when we're going to start getting into training custom object detection modules and instance segmentation modules as well. So each step of this course, it's going to build on top of the other. You don't want to skip any lessons because if you do, you'll miss out on key important knowledge. But for now, let's just discuss what PyTorch is. So here's what you're going to learn today. You're going to learn what the PyTorch library is, how to install it on your machine, important PyTorch features such as tensors and Autograd. You'll also learn about PyTorch support for your GPUs and also why PyTorch is so popular amongst the research community. Then we'll start discussing, what I'll call these sensitive questions in the deep learning community, the type of questions that may provoke people, and you may get some responses on social media or via email, and you get debates on Reddit and LinkedIn, and all that surrounds whether PyTorch is better than Keras and TensorFlow and when you should be using PyTorch, Keras, or TensorFlow. These are kind of the hot button questions in the deep learning community that always gets a rise out of some people. And we'll discuss some of that, and honestly, including some of the ethical considerations of whether or not you should be involved in those arguments. Because, myself and PyTorch developers and Francois Chalet, Keras creator, we have some stories to tell in that space, and it's not all good. And I think as a deep learning community as a whole, we can be much better and much supportive of each other. But we'll get there later in this talk. So what exactly is the PyTorch library? Well, PyTorch is an open source machine learning library. It specializes in tensor computations, which is similar to TensorFlow. It includes automatic differentiation, so it allows you to construct these graphs, these networks, perform forward propagation, back propagation, to compute the derivatives along the way, and update the model parameters. It also includes GPU acceleration because, as you know, training a neural network requires a significant amount of computation. So if you can push that computation to your GPU, you're going to get faster throughput. Your model is going to train faster. PyTorch is also one of the most popular deep learning libraries, the two other most popular ones being TensorFlow and Keras. And PyTorch tends to be very, very popular amongst the research community due to how Pythonic the API is and just the ease of extensibility in implementing custom architectures and layer types and optimizers. And of course, what PyTorch is most famous for is the customizability of your training loop. And TensorFlow 2 kind of allows these APIs to converge a little bit, but especially in the research community, you'll see PyTorch used often here for research. So let's take a second and just examine the popularity of PyTorch and Keras and TensorFlow over the past 5 years. This is Google search trends, so the number of people who are searching for these or similar terms over worldwide. So I'm not limiting the search terms to a specific country. I'm looking overall as the global Earth. What are people searching for? So you can see that TensorFlow's popularity has started to rise back in May 2017 and then continued to rise until about 2019, and then it's declined a bit. And PyTorch's popularity has just continued to rise and then leveled off a bit around 2019. So in terms of search popularity on Google, TensorFlow and PyTorch are really almost the same in terms of popularity. Now, you could make other arguments saying, well, what's the number of active GitHub users committing to the libraries? What's the raw number of commits themselves? How many versions are they pushing out? That's all kind of internal stuff that I don't necessarily think is as important for tracking a given library's popularity, because at the end of the day, what matters is adoption. How many people are downloading and installing the library on their machine and using it for their hobby projects? How many people are using it for research projects? How many people are using it in industry? What's really incredible, though, is you look at the popularity of Keras. It just continues to rise, has these also large peaks as well, which just demonstrates that the library is so easy to use. It's a really great library. to use when you're first getting started with deep learning because it has a scikit-learn style API. And most people will learn the fundamentals of machine learning using scikit-learn before they start studying deep learning. So that knowledge transfers over from scikit-learn over to Keras. APIs are similar. In fact, you can use certain function calls between scikit-learn and Keras almost interchangeably. So there's a natural synergy between the two libraries. So let's kind of discuss the history of PyTorch. PyTorch is based on Torch, which is a scientific computing framework. And prior to PyTorch and Keras and TensorFlow, deep learning packages such as Caffe and Torch tended to be the most popular. And if you've ever used Caffe before, then you know it's not really doing any true programming with Caffe. You're editing configuration files, you're editing a model architecture file, and then you're using the command line to actually train the model itself. Or maybe you're using some of NVIDIA's tools that allow you to train a model in the browser. But again, you're not doing a lot of true programming there. It's just configuration and running commands at the very core. Of course, Python and R are the most popular programming languages for scientists and machine learning practitioners. So it's only natural that as deep learning started to revolutionize the field of computer science, that deep learning packages would be created for Python as well. So back in March of 2015, Francois Chalet, a Google AI researcher, released Keras, and that provided an API for training neural networks. Keras was kind of this high-level API that underneath of it required this computational engine. So at the time, that was Theano, and then it switched over to TensorFlow, and also supported a number of other backends as well. So Keras relied on one of these backends to actually be constructing the graph, performing your forward and backward propagations, and doing all of that heavy lifting. Keras just kind of sat on top of those heavy lifting APIs and made it easier and accessible to work with. So soon after, Google released its first version of TensorFlow in November 2015, soon after Keras released. And due to Google's marketing and popularity, TensorFlow continued to rise in popularity, especially once they coupled it with Keras, and they started to essentially treat Keras as a first-class citizen in the TensorFlow library. And you can access Keras through tensorflow.keras if you were to import that into your Python shell. But there was a bit of a problem back in TensorFlow version 1, and that's that the API wasn't very Pythonic. It wasn't intuitive and easy to use, and honestly, the documentation wasn't that great. So as any good deep learning practitioners would do, they saw the problem. They realized they couldn't shift the focus and the mission of an existing library, so they went and created a library of their own. So PyTorch, sponsored by Facebook, was released in September of 2016, and a lot of that was really rooted in fixing problems people were having with the TensorFlow library. So again, PyTorch solved much of the problems researchers were having with both Keras and TensorFlow. And while Keras is just dead simple to use, by its nature and design, Keras doesn't expose some of the lower level underlying functions that allow you to customize your layer types or your model architectures or your optimizers and your training loops. It's not to say that you can't do that with Keras and TensorFlow. It's just harder. And that's kind of the third bullet point here is TensorFlow gave access to these functions, but they weren't Pythonic. The documentation wasn't that great, and it was hard to combine all the pieces together. So in short, Keras didn't give you that low-level API, and then TensorFlow's API wasn't that friendly for what researchers need to do. So PyTorch solved all these problems by creating an API that was Pythonic and easy to customize. So over time, you started to see these research groups starting to embrace PyTorch and switching over from TensorFlow. And in fact, that's the exact reason why you see so many research groups using PyTorch today. It's because of the lack of functionality within TensorFlow version 1 that PyTorch kind of got its foothold and started slowly climbing its way up in popularity. That said, this whole PyTorch is better for research argument isn't necessarily true anymore. It was undoubtedly true back in TensorFlow version 1, but not so much the case for TensorFlow version 2. And if you go and read the official Deep Learning with PyTorch book, in chapter 1, page 9, you'll see this quote from the authors. And what I bolded the most important part of the quote that says, both PyTorch and TensorFlow have seen their feature sets start to converge with the others. And I like the word converge there because it almost seems like a pun, right? I think the authors purposely chose that word as to not only because it fits the sentence, but the concept of a model converging. I thought that was a fun little quote. But my point here is that PyTorch and TensorFlow, have learned from both their users and from users of the other libraries. They've been on the GitHub threads, they've been in the community forums, they've seen what features have been requested. So now both PyTorch and TensorFlow implement essentially the same functionality and provide the same set of APIs, and they accomplish the same thing, but in different ways and different function calls. All of that functionality is there. So when you wrote custom training loops in TensorFlow version 1, it was a royal pain in the butt. It sucked. PyTorch fixed that. They created these custom training loops that were not necessarily, I'll say, easy to use, because PyTorch doesn't necessarily place that focus of easy to use. That's what Keras exists for. PyTorch exists for that customizability, for that full controlled access to the entire API itself. So PyTorch really allowed researchers to build those custom training loops and build those custom implementations with more ease. Then comes TensorFlow 2, and they solved that issue by a class that you might be familiar with called gradient tape. Gradient tape does a lot of the automatic gradient differentiation that PyTorch does and allows you to create these same styles of custom training loops. So again, over the past couple of years, you've seen the APIs of the two libraries converge together. So how do you install PyTorch? Simple. You just use pip. You install Torch and Torch Vision into your virtual environment or your system environment, depending on how you've configured your Python environment on the machine. Then you can open up a Python shell and import Torch into your programs. Really that simple. Well, let's kind of take a step back now and kind of discuss a little bit of a higher level API, this concept of PyTorch and tensors. So tensors are like multi-dimensional arrays, similar to NumPy arrays, and tensors store inputs to your neural network, your hidden layer representations, and your output. So when you tell PyTorch to connect tensors together and you create this flow, create this graph of data moving through it, that PyTorch is able to understand that. They're able to understand how the architecture is connected, the flow of the data, how to perform backpropagation, update the model weights. And I have a code sample here. And on the upper example is how you would say construct a 2D NumPy array, and they're just filled with random values. And the bottom code block shows you how to do the same thing with a PyTorch tensor. More or less the same style code. So if you're comfortable with NumPy, you'll be comfortable with working with tensors as well. So as I've already mentioned, PyTorch is able to perform backpropagation for us, so we're not writing that by hand. And furthermore, there are multiple ways to construct an architecture in PyTorch. And once PyTorch has this module representation, Autograd kicks in and is able to understand the flow of data through the network and perform backpropagation. So once you've constructed your model architecture, under the hood, PyTorch is assembling a graph of the neural network. It's performing a forward pass where you're making your predictions. Then you'll compute your loss and error using PyTorch functions. And then using Autograd, you could just traverse the network backwards, perform backpropagation, and then update the model parameters such that ideally your next set of predictions will be more accurate. In terms of GPU support, PyTorch primarily supports NVIDIA CUDA-based GPUs. And as you know, GPU acceleration is going to allow you to train your neural networks in a fraction of a time as opposed to using your CPU. PyTorch also supports distributed training, which is fantastic if you want to train your network on large data sets. And what's really nice is Google Colab notebooks allow PyTorch modules to run on Google's TPUs. So if you're a really big Google Colab fan and want to leverage TPUs when you can, there is a way to do that as well. So let's take another step back and look at a high level of why PyTorch is so popular amongst the research community. And we've discussed this already, but it's such an important point and it comes up so often when you're talking to deep learning practitioners that I want to discuss it a bit. The reasons PyTorch were able to obtain such a strong foothold in the research community are many, but the most common reasons are, while Keras is incredibly easy to use, it didn't provide low-level function access that researchers need to perform novel research and implement these custom models and architectures. In the same vein, Keras made it hard for researchers to implement their own optimizers and layer types. That is natural. When you're performing state-of-the-art research, you're by definition pushing the envelope. You're creating things that don't exist yet. So you can't just go over to Keras and say, import this custom architecture that you haven't even created. So that forced researchers to use TensorFlow version 1 instead of using the Keras API. TensorFlow version 1, while it provided those low-level access functions and custom implementations, the API was just quite frankly hard to use, and that dissuaded the research community. So PyTorch came along, and with its Autograd support, it helped resolve a lot of the issues that people were facing with TensorFlow version 1, and it made it easier for researchers to implement their own custom models and optimizers and layer types. And probably most importantly is PyTorch really gave researchers complete control over their training loop. With Keras, you were just calling model.fit and passing in your training data and your validation data. PyTorch doesn't have this concept of a model.fit call. You are responsible, actually, for implementing that fit method. You have complete control over that training loop, which of course just aligns perfectly with the missions of the research community, because just due to their custom implementations and their experiments, they need that level of control. So this slide kind of reiterates that point. There's this dichotomy, there's this balance between the two. Keras really makes it honestly trivial to train a neural network because all you have to do is call model.fit, just like you would do if you were utilizing the scikit-learn library for standard machine learning. The downside, of course, is that researchers can't really modify this model.fit call, and if they could, it would be time consuming and tedious, and quite honestly, probably not worth it. So they had to use TensorFlow's lower level functions. But these methods didn't really make it easy to implement their custom routines. PyTorch solved that problem, which is good because we have complete control over the training process, but it's bad because we could easily shoot ourselves in the foot. Nearly every PyTorch user, myself included, has at some point forgotten to zero their gradients. And if you don't know what I mean by forgetting to zero your gradients, you're going to find out really, really quick inside this course. With that said, let's address one of the most common questions you'll see online, especially amongst those new to deep learning and computer vision. They'll just ask themselves, is PyTorch better than Keras or TensorFlow, and vice versa? What library should I be using first? Much of this debate is starting to settle down, predominantly because both libraries have matured. The APIs have actually started to converge on each other, and the argument really isn't that relevant anymore. Both PyTorch version 1 and TensorFlow version 2, their APIs are so similar that you just go about doing things in a different way, sort of like learning one programming language versus the other. Each programming language has its benefits, its pros, its cons, but both implement essentially the same types of statements and controls. So, like your if statements, your for loops, your while loops, all of that basic syntax is going to look similar in any type of programming language. What's going to differ is like your syntactic sugar, the small differentiating things between the languages. And of course, some languages are better used in certain situations than others, but most of the time you're not going to get in these massive debates over, man, like, is Python better than Ruby? Well, that really depends on what you're doing. If you're talking about web development, Ruby on Rails is phenomenal. And sure, Python, you have Flask and Django, and that's one particular use case. But then you look at the scientific community and you say, is Python better than Ruby? And it's like, well, Ruby doesn't really have as many scientific libraries as Python. So in that case, you might want to consider using the Python programming language. It's the same type of thing with Keras and TensorFlow and PyTorch. You examine what you need to do, and you examine where it's going to be deployed, and then you pick a library based off of that. If you're brand new to deep learning, just don't worry about that. Pick one and learn it, just like learning your first programming language. And I want to kind of wrap this up by saying avoid this concept of entrenchment, where you become so opinionated on something that you start to lash out at others. Francois Chalet, the creator of Keras, tweeted this in May 22, just saying that he was starting to get overwhelmed and frustrated by the amount of hate mail he was getting from PyTorch users that were criticizing him, criticizing the Keras community, and criticizing the TensorFlow community. And of course, this happens on both ends. I'm not singling out PyTorch and saying it's a community of somehow bad users. By no means am I saying that. The actions of a small amount of people have obviously impacted Francois and quite honestly have impacted me as well. I've authored a lot of content on Keras and TensorFlow. And whenever I would email out one of these tutorials and promote it, sure enough, I get one or two emails back from people saying, TensorFlow sucks, Keras sucks, you're an idiot. Like, what the hell are you doing? And like, that's really, really no joke. There were people who would criticize me, tell me I was stupid, that I should have my PhD taken away, and I didn't know what I was doing in the deep learning community. That actually did happen, and I understand at a visceral level what Francois is talking about. Now, does that mean I somehow dislike PyTorch? No, of course not. Not at all. It's a library. It's a deep learning library that facilitates computer vision when applied to those types of problems. PyTorch library is great. And most of the PyTorch users are good, just as most of the Keras and TensorFlow users are good. There are just a small, nefarious number of trolls who just want to get under your skin. So I'll say just avoid the entrenchment. If you catch yourself, getting into a heated debate with someone over whether Keras or TensorFlow is better or better than PyTorch, that's a signal. Step back. Don't get involved in that level of entrenchment. It's just going to create more problems for the community overall. This is probably the most common question I hear from those new to deep learning. They search on Google for like, what is deep learning? And then they read a few articles. And then, of course, those articles mention Keras and TensorFlow and PyTorch. So then they spend a few minutes Googling each of those library names. And then they're like, man, I got these big three, PyTorch, Keras, TensorFlow. Which one do I pick from? Which one do I learn first? If you're just brand new to deep learning, seriously, just pick one and learn it. Do you think PyTorch is a cool name? Great, go learn PyTorch. You think you read somewhere that Keras has a nice API for beginners? Great, go read that. You think TensorFlow is cool? You just like that name better than PyTorch? Whatever, go learn PyTorch. Just pick one and learn it because the APIs, especially between PyTorch 1 and TensorFlow 2, you're going to accomplish the same thing in an APIs that have basically converged on each other. Yeah, there are differences, but not that much. For me personally, I think Keras is really suitable for teaching deep learning practitioners. It's a simple API, and I find that many deep learning practitioners that are new to the world of deep learning already have some experience in machine learning and therefore already have experience in scikit-learn. Keras and scikit-learn just go together. The APIs are similar. And it's also my personal opinion that Keras tends to be the best choice to rapidly prototype and deploy deep learning models. The caveat there is I think if you combine PyTorch and Fast.ai, then you have another solution that's, potentially equal to Keras for rapid prototyping, but Keras just has that stronger API and that stronger documentation, which is why I slightly lean towards Keras for just really, really quick prototyping and getting proof of concepts done. That said, PyTorch does make it just far, far easier for advanced practitioners to implement your custom training loops. Yeah, you can do that with TensorFlow 2. It's far easier than TensorFlow version 1, but PyTorch has always treated that as a first-class citizen. Again, this argument is diminished now that TensorFlow 2 is out, but I still think it's well worth mentioning. But at the end of the day, just realize that APIs have essentially converged between PyTorch and TensorFlow. If you're just brand new to deep learning, pick one. Just pick one and learn it. From there, it's going to be so much easier to go back to the other library and learn that one because you've already learned the fundamentals of deep learning over here. So when you come over to this library, it's going to be easy, just like learning a programming language. It's likely that your first programming language was BASIC, and you probably struggled with the language at first because you not only had to learn your structure and your controls like if statements and for loops and while loops and variable initializations and all that type of stuff, but then you had to learn program flow and design flow, and you had to kind of learn that concept in your head. You had to think very linearly from start to finish. But once you got some skill in BASIC, maybe then you switched over to C or C++ or Java or Python or Ruby. Well, all of that control structure, all of that understanding of designing a program from start to finish and then implementing your loops and your control statements, well, that was far, far easier by the time you got to that second programming language. And all you really needed to focus on was the syntax of the language and understanding the idiosyncrasies of how that language worked. It's really the same thing in deep learning. If you learn PyTorch, then it's going to make it easier to learn TensorFlow because the fundamentals of deep learning are the same regardless. And if you learn TensorFlow first, well, it's going to make PyTorch just as easy to learn. So don't really worry about it. Just seriously pick one and learn it. For the purposes of the rest of this course, of course, we're going to be discussing PyTorch. So come with me and you're going to learn PyTorch along the way. And if you don't know TensorFlow, well, by the end of PyTorch 101, it's going to be really, really easy for you to learn TensorFlow as well. I'll see you in the next lesson.